So for the accelerated geometry final review, this video, I'm going over numbers 15 to 26. So 15 to 26. So now looking here at question number 15, we're first asked, given this situation here, well, how tall is the pole? So this is our X. So I notice, well, here, I'll use the information here because I know that this is 41 degrees with this adjacent side of being 34. So if we have the opposite that we're looking for and adjacent, that's why we're using tangent of 41 degrees is equal to opposite, which is X over 34. So notice you're going to solve by multiplying 34 times tangent of 41 degrees. That's why the answer is B. Now here we're looking for the length of wire 2, so I'll call this Y. So now notice we'll use the 38, and we just technically got that this is approximately, so we'll use 30 in its place. So if this is approximately 30, now we can go through and solve for Y. So this is the adjacent again, but the hypotenuse. So now that's why we're going to use cosine. So this is cosine of 38 degrees. And that is equal to, now this is adjacent, which is 30 over Y. So because of this ratio, that's why you had to solve by dividing 30 divided by cosine of 38 degrees. And you get that this is approximately B, 38 feet. So now 16, these triangles are similar. So PQR, VWX. We are looking for PR. So again, 54 to X, because this is similar, is equal to, well, what's corresponding to 54? The 18. And what is corresponding to X? 15. That's why you have this setup. And again, there's other ways that you can solve this as long as you get that PR or X is equal to 45. So now here, this is definitely make sure to draw a picture so you can see how you're going to solve this. We have the height of two buildings. So we have building 1 is at 34 meters and building 2 is at 24 meters. And again, we're on the ground here. Then the distance between the two buildings is 12 meters. So this distance here is 12 meters. Find the distance between the tops. So we are finding the distance between the two tops here. So if I were to bring this distance up, notice you created a right triangle. This is 12 meters. We're looking for the distance. We'll call that X. Now, technically, do we know what this section here is? Yes, because this is 34 and this is 24. So the difference is 10 meters. So if I were to now redraw and separate this, right? This is a right triangle of side lengths of 10 and 12, and we're looking for X, Pythagorean theorem. So this is 10 squared plus 12 squared is equal to X squared. That's how you get that this is approximately, however you round, 15.6 meters or approximately 16 meters. So now 18 is going back to our interior exterior angles. So angle B, which is here, is 85 degrees. Then angle E, which is here, is 115 degrees. So how do we find the measure of angle C? Well, if you recall, these two angles that are opposite from angle E add to equal 115. So all we have to do to get C is subtract 115 minus 85. That's why C is 30 degrees. So now here, these are interior angles, but what is not one of the angle measures inside? But again, we have to figure out what Y is. These values all add up to equal 180 degrees. So combining your like terms, right? So here, well, we've got 2y plus 3 plus 9y minus 7 plus 7y plus 4, right? All equal to 180. So here you get 18y is equal to 180. You get y is equal to 10. So after plugging in, 23 is an angle, 74 degrees is an angle here, and 83 degrees is an angle here. So that's why the answer is D. Now question 20. Here, this represents a ramp in a parking garage. The safety maximum for safe incline, the maximum is 8.5 degrees. So given this situation of the horizontal is 95 units and the vertical is 15 units, is the ramp safe? Well, first we got to figure out what this angle is. We're going to use inverse. So this is opposite and adjacent. So we're going to use inverse tangent of opposite, which is 15 over 95. That's how you get approximately that this angle here is about 8.97 degrees. So is this ramp safe? No, because this angle here that we got right now is greater than 8.5 degrees, which is the set maximum for safety. So now 21. So here again, if you need to draw the picture, right? So we've got a park here in the shape of a rectangle that is 8 miles long. So 8 miles long and 6 miles wide. So how much, whoops, sorry about that. How much shorter is your walk if you were to walk diagonal versus walking like this, right? So here, rectangle. So I'll finish my rectangle here. So if you were to follow this, you just walked 14 miles. But we want to know how much shorter if you walk diagonally from here to here. So again, notice by doing that, right triangle, Pythagorean theorem. 6 squared plus 8 squared is equal to x squared because you're solving for the hypotenuse. So now notice you get 10 miles. So how much shorter? 4 miles shorter. So now 22. Here's just a basic, going back to solving our triangle here. So you have the angle, we're looking for x is opposite, you have the adjacent. So that's why we're going to use tangent of 25 degrees. So here we've got tangent of 25 is equal to x over radical 11. Now, so what if there's the radical, right? We're going to solve this by multiplication. So radical 11 times tangent of 25 degrees. You get that x is approximately 1.5 yards. So now 23. You're given that these two triangles are similar. So if it's hard for you to see, then redraw. So A, B, C, where AB is 8, BC is 4, and AC is actually what we're looking for. We don't know this, so I'll put X here. Then I'll recreate AED. So AED, so it's in the same order. AED, ABC, AED. AE is 4, ED is 2, and AD is 3. So I noticed to go from our small to large, we're just multiplying by a scale factor of 2. 2 times 2 is 4. 4 times 2 is 8. So 3 times 2 is 6. Now you could also set up your proportion and cross multiply and solve for x. So now 24. 24 here, you have to make sure that you have, if you need to redraw this, so you can just focus on this side here with our BEC and our information. So I'll redraw. Because notice that this is 7, this whole side is 24, and this side here is 25. We are also given that BF bisects this angle. So we have an angle bisector. So that means that these pieces are congruent to each other, or I'm sorry, similar to each other. So we can set up our ratio. The problem is we don't know either of these two pieces. So let's just say we are looking for EF, right? So let's focus on EF. EF is X. So if I have 7 to X, then that means that's equal to 25 to, well, what's the other piece? Well, we can't use 24 because that's everything combined, but we can use 24 minus X. Because again, it's the total subtracting that section here to get the other piece this missing piece here. So now when you cross multiply and solve, you get 168 minus 7x is equal to 25x. So now you can go through and solve this equation here for x. And when you solve, you should get that x is equal to 5 1/4, 5.25. Because again, add the 7x, right? Because you get 168 is equal to now 32x. So this piece, EF, is 5.25 feet, which means how do we find CF? 24 minus the 5.25. That's how you get 18.75 feet for CF. So now 25. Here you're using triangle proportionality theorem because these sides here are parallel to each other. So again, our pieces, our sections, 75. And then here, but notice again, you're given not this section. So we're going to have to set this up as 75 to, well, the total is 96. So 96 minus 8x plus 8, right? Take that piece away. That's how you end up with 88 minus 8x from 96 minus the 8 here. Then that is equal to our other section, which is 45 to 8x plus 8. Now, there are other ways you could solve this. Now, you still have to use, though, because 75 is corresponding with this section, which is, again, the 88 minus 8x. However, if you also wanted to set this up with the totals, then you have to make sure that here you have 120 to that total of 96. So again, no matter what, when you cross multiply and solve, you get x is equal to 3.5. But again, triangle proportionality, when these sides are parallel, the sections here are proportional. They create the ratios. So 26. This is actually going back to the concept of Pythagorean theorem. How here, oops, sorry about that. You're given the right triangle, so you have a squared, b squared, c squared. So if you're looking for here, that means usually to solve for a leg, you would subtract the area of the two squares. That's why the answer is B. Because again, if I were to add the area of the two squares together, you get the square of the hypotenuse, which is 841.